All right, for this problem, we have to prove that these two triangles are similar using a flowchart. Now, keep in mind we've got three options for doing this. We can either use side, 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 angle, side, or angle, angle. So first, let's take a minute to determine which one of these theorems is going to be the best to use for this situation, okay? Now, it looks like if I look at the inside of my triangle here, I don't have any information about the angles in there whatsoever. None of the angles are marked, and none of the angles have any numbers in them at all. So we don't have any information about the angles. That means we can't use angle, angle, and we can't use side, angle, side, because we don't know any of the angles. So that leaves side, side, side. So let's check to make sure that we have all three sides labeled for each triangle. We've got this one, and this one. All right, so this is the smallest side, the middle side, and the biggest side. And then we've got the smallest side here, the middle side here, and the biggest side here. So we do have all three sides for both triangles, which means we can use side, side, side. So let's go ahead and draw our boxes out. Okay, and keep in mind we're going to pair up the two biggest sides, the two middle sides, and the two smallest sides, okay? So let's do the biggest sides first. We've got 14 and 28. So 14 and 28. Let's go ahead and name those sides. Side that's 14, the points on either end are S and T, and the points on either side of the 28 are L and K. Okay, and when we simplify 14 over 28, we get 1/2. All right. Now let's look at the middle sides. We've got SJ, which is 12. We've got LJ, which is 24. And for our smallest sides, we've got JT, which is 6. And JK, which is 12. And if we go ahead and divide these out as well, 12 divided by 24 will give you 0.5 in your calculator, which is 1/2. And we get 1/2 for everything. That means the ratio of all three sides is the same. So the scale factor 1 to 2 would give us one of the triangles made bigger. So all we need to do now is we need to take these pieces of evidence and we need to write a similarity statement telling which triangle is similar to which triangle. So we're going to draw arrows, and I'll make a box for our similarity statement as well. Triangle something is going to be similar to triangle something. So let's see, let's go back up here, and I'm going to erase some of this stuff so that we can see what the names of these triangles could be. All right, so let's see. Our first triangle, let's just go ahead and name that JTS. So it doesn't matter what we name our first triangle, but when we name our second triangle, we know the angles have to correspond. So J was between our middle side and our smallest side. So if we look at our bottom triangle, we need to make sure that our starting point is between our middle and our smallest side as well. And that's going to be angle J for the bottom triangle as well. Okay. Now we went from J to T. J to T meant we went along the path of the smaller side. So if I start with J, I'm going to go along the path of the smaller side, and that's to K. So JK, and of course our last one has to be L. And that is the full proof showing that these two triangles are similar. We have our pieces of evidence, which is in the boxes, and then our conclusion, which is our similarity statement at the end.